everyone. I welcome you all to the Statistician Hub. Myself Aditi Chakraborty and I am a PhD research scholar at IIPS Mumbai. Today we are going to learn how to perform a binomial logistic regression and to draw a forest plot in STATA. So what is binomial logistic regression? A binomial logistic regression is used to predict a dichotomous dependent variable based on one or more continuous or nominal independent variables. It is the most common type of logistic regression which uses binary outcome variables, and therefore it is also known as a binary logistic regression. Now, for example, with the help of a binomial logistic regression, we can predict the likelihood of diabetes by considering factors like age, body mass index, family history of diabetes, smoking, and drinking habits. So now before we go to STATA and learn about our data, let us first go through the assumptions of binomial logistic regression. So the first assumption is that the dependent variable should be a dichotomous variable. There should be two or more independent variables which should be measured at continuous or nominal level. The observation should be independent. The data must not show multicollinearity. There must be a linear relationship between any continuous independent variable and the logic transformation of the dependent variable. And lastly, there should be no significant outliers, high leverage points, or highly influential points in your dataset. So now let us go to STATA. By typing BR in STATA, we can browse our data. So now this is our data. The data has been collected from 100 individuals. The second column here talks about the diabetic status of the individual. 0 here implies that the individual doesn't have diabetes, and 1 implies that the individual has diabetes. The third column has recorded the age of the individuals. The fourth column has recorded the BMI status of the individual, where 1 implies underweight, 2 implies normal weight, 3 implies overweight, and 4 implies obese. Now the fifth column has recorded the family history of diabetes of the individual. 0 here implies that the individual doesn't have a family history of diabetes, and 1 implies that the individual has a family history of diabetes. Now the sixth and seventh column here has recorded the alcohol consumption habit and the tobacco smoking habits of the individual. 0 implies that the individual doesn't consume alcohol or doesn't smoke tobacco, and 1 implies that the individual consumes alcohol or the individuals smoke tobacco. So this is our data. Now let us move on for the analysis. So now first of all we will recode our age into 5 categories. So for that we will copy this command and we will paste it here. So these will be our 5 categories: 0 to 19 years, 20 to 39 years, 40 to 59 years, 60 to 79 years, and 80 years and above. Just enter it. Our new variable age has been generated and it is in 5 categories. Now let us copy this command which will help us to run the regression analysis in STATA. So it is logit, the diabetes, which is our dependent variable, I.age, I.BMI, I.family history of diabetes, I.alcohol consumption, and I.tobacco consumption, which are our independent variables. So let us enter it, and here is our result. So the number of observation is 100, LR chi-square 80.18, and probability greater than chi-square, that is p-value 0.000, here implies that our model is a good fit in comparison to a null model, and pseudo r-square is equal to 0.5844 implies that 58.44% of the variation in our dependent variable is explained by the variation in our independent variables. Now let us move on to the table. So here the first column talks about the coefficient of the regression analysis. The second column gives us the standard error. Third column gives us a Z value. Fourth column gives us a P value. And the fifth and sixth column gives us the 95% confidence interval. So here we will be measuring the significance by using a p-value to be 0.05. So now here you can see that the p-value for the age group 60 to 79 and 80 and above is 0.3030 and 0.014, which is less than 0.05, which implies that these two age groups are significantly associated in predicting the diabetes status. So the reference group here will be 0 to 19. So we can say that as an individual moves from the age group 0 to 19 to the age group 60 to 79, he or she has a significantly higher chances of getting diabetic in comparison to the reference age groups. And this coefficient tells us about as we move from 1 unit change from the reference group to the group of consideration, 4.72 times the chances of occurrence of the diabetes increases. Similar interpretation can be made for the other independent variables. So now let us see how to draw the forest plot in the STATA. So this is the command for drawing the forest plot in STATA. So that is coef plot, comma, drop the constant, and x line is equals to 0 implies x line is the reference line. Here the coefficient for the reference category, all the reference categories is 0. So the reference line is at 0. Now let us enter here, and here you can see that this is our forest plot. So here the dots implies the value of the coefficient for the various categories of the independent variables, and this line is the reference line. And these lines are the confidence interval. If the confidence interval touches or crosses the reference line, then the categories of the independent variables are not significantly predicting the dependent variable. So here we can see that for the age group 60 to 79 and 80 and above, the confidence interval lines are not crossing the reference line, and hence we can say that these groups are significant in predicting the diabetes status of an individual. And similarly we can see for the others also, like overweight and obese, family history of hypertension are significantly associated in predicting the diabetes status of the individual. So here is how you can perform a binomial logistic regression and draw a forest plot in STATA. That's all for today. Thank you.